Hello and welcome back to part 2. I'm going to show the process now that I use for putting in ICs, making ground connections, and also doing a run of power and data, etc. So I start first of all. We've got some standard 16-pin dip sockets, small piece of protoboard that we're going to be using just for demoing. So for example, say I want to put these three sockets on here for chips, and I don't want them too far away because there's very few components between them. Maybe there's only a couple of resistors or capacitors or something like that. So I'll space them equidistant. Now if I turn that board over, everything's just going to fall out. So what I tend to do is get another piece of board, put it on top and just turn it over, and I can put it down on the ground like that, and I've got my places. I can actually see the pins sticking through. And what I then do is just tack very quickly a pin on each chip like that. I can lift that board up now. The chips are on there, the sockets are on there. Now sometimes they do have a bit of wobble on them, so I just tend to push with my thumb or fingers from one side against the socket and then just touch it, and you hear that click, and that means there's a very gentle click that you get, and that means that the socket is sitting down better on the board. So that's all down there. Another clean, and you can go through, solder the socket to the board. Just do these very quickly. I haven't got my ventilation system on because it's quite noisy and you won't be able to hear what I'm saying. See, yes, I spilt some solder onto the board because I didn't clean my soldering iron as I was going along, because I'm trying to be in a rush, which is the wrong thing to do. We can fix that easily enough. The important thing is getting everything soldered. I think my hands aren't too shaky for a 61-year-old. There we go, that's all the pins soldered, and we'll just take solder sucker to that location, clean that up, and start again. There we go. Right, so that's the socket soldered to the board. I have orientated them all the right way around. What I do now is a little colour coding trick. Again, I work out which is pin 1, which is this bottom, which becomes here. I put just a blue blob. You can see the blue blob there. That's just a reference for me that I know that that's pin 1 on that chip. So when I'm looking from underneath, I've got the orientation without having to turn the board over and guess what the hell it was. Sometimes I go even further. Sometimes I actually think to myself, okay, well, it's a logic chip, so its power will be probably pin 16. So that's that. And its ground will probably be pin 8. So again, I can put a black blob against there. So that just helps me think when I'm wiring what I need to do. Now, if it's a logic chip, it's probably going to need decoupling with a 100 nanofarad capacitor, which helps us because we can use the 100 nanofarad capacitor as an extra pin. So if we take the power, which is pin 16, as you can see there, and then the chip there near pin 1 as ground, you can just do that basically. Just tuck the chip, tuck the ground in, and then pull the power one back over. Take your nice cheap blue snips, snip that. Don't throw them away, they're very useful. They're perfect for little joins if you need to make a ground or a connection to something. I have oodles of them, which I just keep as spares. So as you can see, you've got your ground wire basically built in for you onto there. Solder your power and then solder your ground on, and just make a little jumper like that, and there you have a nice decoupled chip and extra wire for a piece of logic. So that's pretty straightforward. Now we'll base this logic being 5 volts and I'll do the same for all of these, but it's going to take too long in the video, so let's say that that's 5 volts. You take my orange wire, take my stripper, just strip a little bit off, have a look at the distance between them using the measures, and it's approximately 4 between them. So because 4 is the exact distance, I'm going to make it 1 more, I'm going to make it 5, and I've got 2 runs to do, so I'm going to do 5, measure, cut, 5, measure, cut. As you can see there, oh, this is another useful thing for these little pliers, just to pull the wires back so you can sort them out. Now snip off the extra bit, tin the wire, plug it on the first power connection, that's on, bend it into shape for the second, it doesn't have to be exact, tin the wire again. Would normally be a bigger connection here because you'd have the decoupling capacitor, but you can just basically do that. And then same again for the third chip, bend that into a nice little loop. Take that onto there. I'm actually quite nervous doing this. I've never done videos like this before. This is where this little thing comes in useful as well, because you can just try and straighten out the cable runs, make them a little bit neater. Now you see I didn't actually cut the end off here, because usually you want to go somewhere with it, so that would be going off then to maybe a power connector up here, so you'd cut that off and take your tool, cut the end off. You probably have a power connector here, so you solder into a power connector. Ooh, shaking like crazy. Solder that to there, and that's your power connection made. Probably 0.1 inch power connector on the end there, and that's your little power undone for your chips. And that's quite quick. I mean, people say it must take me ages to do these things, but even though I'm nervous and even though I'm hot and sticky, that wasn't too long. Of course, like I said, I'd have decoupling chips in there, and my ground runs, again, I would just take a piece like this, and I'll just lift that up a little bit. this might be part of the ground plane that I'm running pretty close to the chip. I'm making quite a thick solder connection there. Probably help if I clean the tip. You can see I've made a ground connection to that. I'm not happy with it because it's not central, and my OCD kicked in. So make another one. And that's my power connection, my ground connections, and I can use my pliers. Just make a bend on that. Just make a bend on that. Now what I'll probably do is just tack these down, because then they stay on the board like that and like that. And you can sort of pull that straight. Well, that would be your power connection to there then. I wouldn't normally have such a long connection from some chips to the power connector, but this is just for demo purposes. There you go. And you can also just put little tack of soldering on that just to keep it in line if you think it's going to move around and cause a short. But it generally doesn't move once it's soldered in. And this other power can be going to other places. It's like I say, it's just a demo of what you do with it. So that's running power and ground into some logic and some decoupling. And then obviously you want to use your white wire to make connections. So say these are all 4051s and I want to connect the 9, 10 and 11, which are address A, B and C chips. So these are too short, as I said. These are actually 4s, too short, so just drop them off. A little pull of cable. We'll do some 5s. So 1. God, my hands are sweaty. 2. Pull them back a bit. Easy with the pliers. Chop that off. And it's pretty much the same as the power, except you're doing data. So we'll do pin 9 and loop that in to there. And same again. Solder getting in the way. Nerve taking over. Here you go. So there's your first address line A, or C, I think that is actually, of the 4051. And you can tidy them up, you don't have to be a mess. And you do the same for the next 2 and take that off to wherever that's going. Like a processor or whatever that's controlling those address lines. So that's basically it. Gives you an idea. What I'll do is I'll just add a couple of, well, Do you need to see a resistor going in? Let's see. If I put a resistor in, pop a resistor through, and I'd bend the pins over like that, and then I'd tack the first one. Like so, and cut it, and cut the second one at the same time, and just make sure I remember to solder that, because sometimes I forget, not often. This is what I was saying about bad connections. Sometimes when you do these and you put your resistors in like this, you can make the mistake. It's like a spark plug head. You've got the centre pin, and you've got the little hood that goes over it, and the little hood being the resistor leg, and they're not joined, which is no good for a resistor, obviously being connected to a chip. So you've got to remember, one, to solder them, and two, to make sure that they make connection properly. So that's when looking with the magnifying glass helps, because you can actually see, you can't see it but I can see, that it's not a spark plug head, it's actually made connection. So that means my resistor is actually doing its job and everything's hunky-dory. So that's where most of my faults come from. I have spark plug heads and I don't want them. So there you go. That's it for now. Maybe you need some more, but I don't know, I'll put this one up and see what people think.